Welcome. Let's take a look at some polynomial functions, specifically some vocabulary about leading coefficient in standard form first. The degree of a polynomial is the highest exponent. Highest exponent. Leading coefficient is the one for the first term. And the standard form is in order by exponent. So let's do that with this. So we see that the largest exponent is 4. So that has to be put first. So I'm going to rewrite it with that put first. And then that's gone out of here. And then this next one is because it's the next largest exponent. This has the next largest exponent. Notice that I'm careful to keep the minus with the 15. And then plus 3x. Because that's next to the first power. And then minus 1, because in reality, although we don't see it, there's an x here, but it's x to the 0 power. So we have 4, 3, 2, 1, 0. But x, anything to the 0 is the number 1, so we don't need it. So this is the degree. This is the leading coefficient simply because it leads off the polynomial. And standard form because it's in order by the exponent. So this does answer the question, what are the three things? The 4 because it's the highest exponent, the 7 because it's the coefficient of the first term, and in order is by exponents, 4, 3, 2, 1. To evaluate simply means to substitute. Substitute and calculate. So we're going to take that negative 3 and we're going to put it inside here. We're going to call it f negative 3 equals 2, negative 3 squared minus negative 3 plus 1. So the function at negative 3 is equal to 2 times 9, because negative 3 times negative 3 is positive 9, plus 3 plus 1. That's the number 18. So f of negative 3 of the function, when negative 3 input value of the x, leads to a result of 22. 22, that's what I thought. Now, this next one has the same concept, but now we're going to put a binomial in place. So it's f of x is equal to, actually, it's not x. So it's with the polynomial. In place of x, we have 2x minus 1. It has an x in it, but it's not the same as just the x is equal to 2x minus 1 squared minus 2x minus 1 plus 1. Okay, so errors. This is a place that people tend to make an error here. And here's a second place where people tend to make an error. So what I'm going to do is I'm going to show you how to do them correctly. First one, 2x minus 1 squared is not equal to 4x squared plus 1. So that's trying to distribute the 2 over here, and that is not the correct way to do it. Instead, remember what squared means. When you have an exponent, it means raised to that power. It means repeating it times itself. So we actually have is 2x minus 1 times 2x minus 1. So it's 2x times 2x is 4x squared, but it's a minus 2x, a minus 2x, and a plus 1. So we do this, but we also do this, and we also do this, and then we multiply this one, we get the plus 1. And these can combine, of course, to negative 4x. So over here, 2x minus 1 equals 2 times 4x squared minus 4x plus 1. And that's from combining the minus 2x and minus 2x for the negative 4x. Well, let's now continue this, negative 2x, and not minus 1, but plus 1. The other error that sometimes people make is that they distribute to that, but they forget the other one. So they'll do negative 2, oops. Yeah, no, I had that right. Negative 2x plus 1, that's what it should be. Because it should be going to there, the two negatives make a plus. And that's why I put negative 2x plus 1 for this, and then another plus 1. We have a bunch of plus 1s here. This is the one that's key. Because we distribute them. Yeah. Just to show distributing both. Now let's clean it up. 2x minus 1 equals, I'm going to multiply 2 times 4 is 8x squared. Now, I'm going to do 2 times negative 4 to get negative 6x. But there's another negative 2 there, and so I want to combine it. Okay. Oh, this one's not negative 6, it's times, it's negative 8x. And then that's 2 times negative 4x is negative 8x. Minus 2x gives us negative 10x. And then here, this was plus 1, plus 1 is plus 2. Another plus 1 will give us 2 times that will give us 4. So we have 8x squared minus 10x plus 4. I'm thinking too much of it. I'm going to show here that we get 2 times 4 is 8x squared minus 8x plus 2 minus 2x plus 2. That's where these go together. These go together, so you have squared minus 10x plus 4, and that's what we used here. Now, there are 2 practice ones for this, so good time to stop the video, work them out. I'll start talking in a few seconds. So, well, great. Now you will return from working those problems out yourself. And so let's go through and do these here. So f of negative 4 is 3, negative 4 squared minus negative 4 plus 7. The negative 4 squared is positive 16. And so we get 3, 16, 16 plus 4 plus 7 because of the double negatives. Now we have 48. 3 times 16 is 48. Plus 4 is 52. Plus 7 is 59. Now let's do one again with the polynomial. So 3x minus 5 goes inside here. 3x minus 5 squared minus 3x minus 5 plus 7. So first I'm going to do the squared part here. Side. 3x minus 5 get 9x squared minus 15x minus another 15x plus 25. So we get it where it's minus 30x plus 25. So this is equal to 4. 9x squared minus 30x plus 25 minus 3x, and then also plus 5 plus 5. And a bunch of things. Now I'm going to multiply 4 into each of these. Gives us 36x squared minus 120x plus 100 minus 3x 12. And we'll combine the x's and we'll combine the numbers. So f 3x minus 5 is actually equal to 36x squared minus 123x plus 112. Let's look at the next page. So some more things that are in this lesson is to look at top of page 210 for the differences between different types of polynomial functions, but also look at the top of page 211 for what's called even and odd degree coefficients. Those you can do yourself. I am going to have us focus now on what end behavior is. The concept of end behavior is what happens to a function as it moves along the x-axis. So what's it doing? So let's take an example one that is basic x cubed. Down sort of here. So what this is talking about is what happens when we go on the x-axis. As it moves along the x-axis towards negative infinity, what is happening? Look at, and then the other way, as we move towards positive infinity, what's happening? So let's take this first one. The function of x as x approaches, I'm going to put negative here now. Okay, so that means we're going this way here. As the function of x as it approaches negative, or the function of x approaches negative infinity as x approaches what? Well, what happens to a function as it moves along the axis? We'll recognize that there's a very specific format that you have to follow, and it's this. The function of x approaches something as x approaches something. That's usually the function of x approaches, it could be a number, infinity, or such, but here as x approaches negative infinity or infinity. And that's because of what happens here on the graph. We're either going this way to see what happens as the function goes to the left, one end of it, and here as the function goes the other way towards positive infinity. So what this is written is that the function of x approaches, and I'm going to write the word here, approaches infinity as x approaches infinity. But here, we're going to do the function of x. Well, actually, I need to put one in here. The function of x is what's happening on the y's. What is the actual graph doing? The graph, meaning the graphed function. The graphed function, which is the one in blue. It's going down to negative infinity. It's going down and it's going over and over. Well, it's going down on the y's all the way down to negative infinity. So we need to put negative there. And it's happening that way as the x is approaching negative infinity by going to the left. We're going to put negative infinity. That takes care of going this direction. Next, we're going to be looking at going that direction, to the right. So here, the function of x is going up to positive infinity. We don't have to write it, but I don't mind writing positive infinity. It's not required, but safe. It's a safe thing to do. And that is happening while the x-axis to the left, to the right rather, while it keeps going out towards infinity. And that's a positive infinity for that. So, having looked at that, let's take a look at another one. The upside down parabola. Okay. So I'm going to say that the function of x approaches, and we just use, it's supposed to be a filled in lines for it, approaches negative infinity, it's this one down here, as x approaches negative infinity, because it's going out this way. So as this function drops down, it's actually also going that way, which is why it's going sort of on diagonal. So that's one point, but then also the function of x approaches negative infinity this way, and x approaches positive infinity, because the x values are going out this way as the y values are going down. Notice this has a negative and a positive. Okay, so that's what we consider the solution here. And it has to have two parts, one going to negative infinity and one going to positive infinity with these values. And one important point for this is I will only accept this format or one exception to it. One exception to it is taught in the next level of math in pre-calculus, whereas in integrated 3, this was being shown this way. The other way to do it is to lead off with the x's. We would say x approaches negative infinity on this top one. X approach, what? No, it's supposed to be as x approaches negative infinity. The function of x also approaches negative infinity. Then we would say as x approaches positive infinity, function of x approaches negative infinity. And so you can match that up. X approaches positive infinity, is the one that's going this way, but the arm is still going down, so it's still going to negative infinity. Okay, but this is also an acceptable way to write it, but it has to have commas in it too. Notice that because of the grammar that's used. So either of these ways will work, but since the textbook is doing this way, which is this one, the textbook's doing that one, that's the better way to do it. So up here it was all of this. Here you can see it written out ourselves. So be careful about this end behavior. Beginning now, you have to write end behavior in this method. I'll get that star handwritten, we can just set it to stay. Okay. That's 1 minute. Well, I hope this helps with looking at writing polynomial functions in the standard form, those things, evaluating it, and then between that one's pretty fun to be able to do at home. So that's all. Thank you for watching this.